Welcome to the data channel, and you're watching SQL Bootcamp for Data Professionals. As part of topic 15, we will be discussing about clustered versus non-clustered indexes in SQL. So in SQL, definitely you might be knowing about indexes, which is definitely used for improving the performance when you're retrieving the data and especially for data retrieval operations, right? And it is meant for decreasing the IO and the CPU that is needed for the calculation. So that's why the reason is you use the index and you get the results faster, right? And in this video, we will especially understand the difference between clustered and non-clustered indexes. So it's quite important to understand these different categories or different types in SQL. So that we will discuss in this video. Before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So first of all, what is clustered index? So clustered index determines the physical order of the data in the table. That means how the data actually stored physically in a table. So let's suppose there is a table, right? So you have an employee table, right? And so you have an employee ID column, and then you have rest of the columns like first name, last name, location, salary, etc. But whatever qualifies as the employee ID, which is a primary key here, right? So that determines that how the data is physically stored, right? As per the cluster index. So there can be only one cluster index per table. That's like ideally it's a primary key which will act as a cluster index because the data row can only be sorted in one order, right? So suppose you have a primary key as an employee ID. So based on that employee ID, it starts with, say, for example, 1, 2, 3, 4, and so on, right? So this is a particular column which acts as a clustered index, and this is how the data will be physically stored in the memory, so that when you're retrieving the data, so the order of retrieval will be in the order of the how the primary key is sorted, right? So that's the definition of a cluster index. But how the data is exactly stored? The data is stored in the same order this as sorted in the cluster index. So that's what we were saying, right? Right. So suppose there are 10,000 employees, right? So it starts from 1 and it goes till 10,000 rows. So the data is stored in this particular order from 1 to 10,000. It will be stored in that particular order. So rest of the columns might be different. It doesn't matter. But the data physically stored as per this particular column, which is an employee ID, and it is a primary key, and that primary key acts as a clustered index. So basically indexing, right? So indexing is basically kind of it's like a pointer. So to access or retrieve the data in a faster way. So this particular cluster index acts as a that retrieval key, which is a primary key in this case, right? And it will be the data will be sorted in that particular order, and it will be stored. So let's take example of a phone book, right? You have a directory or you have a phone book where the entries are arranged alphabetically by name, right? So similarly here, so whatever the column you choose, like it might be a employee ID, it might be employee name, so whatever it might be, right? So based on that, generally in 99% of the cases it will be a primary key, which is the ID column, right? So you can choose any other columns as well, but ideally it should be a unique identifiable column, which in this case it will be a kind of a employee ID or any identifier column, right? So next, the structure. So what is structure here, right? So we understood the storage, but if you go little deeper, how exactly the data will be stored, right? So let's suppose structurally the indexing will use something called as B tree. So B tree, if you know about a data structure, it is nothing but it is like a B tree structure. It is a kind of a data structure, right? So what happens is in a BT structure, let's suppose you have something like a root node. So this is a root node, okay, where this is an entry point. Like suppose whenever you query, right, where employee ID equals to 10, right, you query like select star from employee table, where employee ID equals to 10. So whatever query you throw, right? So that query will go to this root node. So this is like a root node, and then this is like an entry point, what we call it as. So after that, it splits into the intermediate nodes. So there might be n number of intermediate nodes based on the how the data is stored, how the data is actually having split across, and based on the memory, based on the IOs that it has to perform. So these are all intermediate nodes. Again, this can have a number of nodes, right? So B tree is nothing but it is a kind of a data structure as we mentioned, right? And this is how the data will be stored. So it goes on, right? It can be a huge tree inside. So whenever the entry points comes in, right, like employee ID equals to 10, it goes and see. So maybe here it might be storing from 1 to 10. So here it might be storing from 10 to 20, something like that, right? And here again 1 to 5 it can store. So it depends. It dynamically decides how exactly the data should be stored in a structure wise in a B tree format. But this is how it looks like, and this is like root node what we called, and these are the intermediate nodes, IN, intermediate nodes, right? So finally at the end we will be having the leaf nodes. So here we will be having something called as leaf nodes. So leaf nodes are nothing but where the exactly the data is stored. Like suppose, so here we queried, right? Here 1 to 10 is a hash key. So again 1 to 10, 1 to 5 was the hash key. So here it might be a 6 to 10. So it will come to this node, and then it will go to the exact pointer where the data is stored. So here is exactly the data is stored, and it will retrieve the data and give it back to the user. So I hope you understood the concept, right? Here the main thing is root node, intermediate node, and leaf node. So here when it comes to the leaf node, like let's suppose the leaf node is like say 10,000. So this 10,000 indicates the contains the actual data of the table sorted by index column. It is not holding the pointer, it is holding the actual data itself. The address 10,000 is actually holding the data itself. It is not pointing to any pointers where the data is stored. So it is directly having the data itself. So unlike non-clustered index, we will see in a moment. So next we will go to the use case, right? So use case is nothing but so the best for columns frequently used in a date range, like suppose you're using a dates or a sequential data, and so as we saw, like where we have a employee ID columns, order ID columns, transaction ID columns, etc., where you have that cluster index use case to be used. So suitable for primary keys as they provide unique ordering. What are the pros of it? Like pros is like faster retrieval of data for range queries, and also it improves the performance for sorting and grouping as well. And there are some drawbacks also, like there will be slower inserts, slower updates and delete operations. The reason is so the reordering of the rows might be required, because see whenever you insert a particular row, right, or update a particular row, so which is based on the ID. So as we discussed, the structure will be impacted, right? Like suppose there is a column deleted, the row deleted here between this 1 to 10 range or whatever, so it has to align accordingly. So the structure of the B tree will get impacted. So that's the reason. So it impacts the inserts, updates and delete operations will become relatively slower, and cannot have more than one cluster index. So that is another one of the drawback that we can see in the clustered index. So let's move to the non-clustered index. So by definition, non-clustered index means it does not alter the physical order of the data in the table, right? So like clustered index where it was a physically operating on the data directly, right? But non-clustered index does not operate physically on the data. Instead, it creates a separate structure to maintain the pointers to the actual data rows. So storage is like the data rows are stored independently of the non-clustered index. It's like the index at the back of the book pointing to the page where the topics are to be discussed, right? It is like a catalog. It is like a metadata basically, right? So clustered index is not like a metadata. It is directly like a dictionary where you find something and there is a data directly to that, right? Associated with that, or it is like a telephone directory where you search the name and you have the contact for directly for that. But non-clustered index is like a it's defining the definition of the data. It's not directly giving the data. It is like a master data. It is like a kind of a holding a catalog of the data basically, right? And structure, this is quite important here, right? So here, like cluster index, this also holds the um, kind of a B structure only, similar to the cluster index, but the leaf node that we discussed, right? So like suppose we were discussing, so there is a root node, there is a intermediate nodes, right? Intermediate nodes can be a number of nodes, right? Like there can be a number of nodes here, right? Root node is there, intermediate node is there, and finally we have a leaf nodes. Okay, so in case of clustered index, what used to happen is the leaf nodes used to have um, contains the actual data rows of the table sorted in the by the indexed columns, right? But in case of non-clustered index, what happens is here the data actual data is not stored, but they contain the indexed column value and the pointer row locator to the actual row. So suppose that there is a 100 here. Okay, so 100 is not a data actually. This location does not hold the data. So you have to go to this location in the physical memory, right? And this particular data is not actual data, it's a pointer to a data. So then there will be something called pointer. So you need to take that pointer and go to the actual physical memory to get the data. So by doing this, what exactly the difference it is making if you really understand. So in the cluster index, if you touch the data, you are physically touching the data. If you do any updates, insert, because so it is not physically changing anything in non-cluster index. But in case of cluster index, the if you touch the data, it is physically touching the data because the all the data which is stored in the format of B tree is actually the leaf nodes are actually holding the data itself, pointers to the data itself. But here it is holding the pointers to a pointers where the data is stored. So that is the reason if you change here, like if you change the data, like instead of if you delete or update any data, the structure of the B tree will not is not getting impacted here because it is just holding the pointer to that location, right? So that's the advantage of it, and ideal for cases where you have columns frequently used in searches. Example, email address or customer names. You give a select star from employee where employee name equals to something, right? In that cases it can be used, and in that case you make a employee name or customer name as a non-cluster indexed column. So used for querying that does not return a large data set. So this is quite important, right? So here you need to understand, because if there is a large number of data sets that is involved, so you should not use the non-clustered index because there will be a lot of pointers you need to get, right? Suppose there are like 10,000 rows, so you need to get 10,000 pointers, and these again 10,000 pointers has to search a lot of data where exactly the 10,000 to retrieve the 10,000 records, right? So that's pretty important because there is a two-step approach in the non-clustered index, right? You have to go to the pointer, so then you go to the data, right? But in case of clustered index, it was directly the data you used to get, right? So that's quite important. So what are the advantages? Advantages are like multiple non-cluster index can exist in a table. Like suppose you can make email ID, you can make customer name, you can make the location, like n number of columns you can choose to perform a non-clustered index, right? And you can also have faster retrieval for individual lookups. Like if you have an individual lookup on a particular columns, you can have it as a faster in case of non-cluster index. And what can be cons? Cons is like additional storage is required to for maintaining the index structure, because here so we have a pointer or an index. right? And then we have a data. So if you have 10 million rows, 10 million pointers will be there. Again, 10 million data rows will be there anyways. So for this 10 million rows that you are having, that is creating the 10 million pointers here. So definitely you need additional storage for maintaining those indexes. So it can be slower when it is kind of having the slower than a cluster index for retrieving the large range of data set. So because that is that we already discussed, because there is extra pointers involved here, and all these pointers need to be converted into a or parsed to a actual data. So if there are thousands of rows that you are retrieving, so then you have thousands of pointers. So these thousands of pointer will lead to a thousands of data. So that can lead to a slower when it compares to the cluster index. So that is in case of a large data set retrieval. But if you are going for the small data set retrieval, like where employee ID or employee name or email ID, so then non-cluster index will be faster than the cluster index. So let's summarize the key difference, right? We will consider a few aspects here. The aspects is like a physical data order. So here, in case of cluster index, as we saw, it alters the physical data order. Physically, it is touching the data whenever you do updates, inserts, or deletes. But in case of cluster index, because we are working on the pointers, so the B structure is created based on the pointers, not on the actual data, so it doesn't hit the physical structure, right? And the number per table, so it is only one you can create, but here you can create a number of columns as a non-cluster index. And structure data stored in the indexed structure, so here it is stored in the pointer to a data rows, right? It is a pointer here. Here it is directly to the index directly to the data store, but ideally both are using B tree structure as a data structure concept. But what is stored is different, right? And coming to the performance, faster for a range queries. That means you have a set of data to be retrieved. Like you have a, say, employee ID between say 10,000 to um, 20,000. So you have a set of 10,000 records to be kind of retrieved, right? Or you have a date range, right? So between the date range like 2022 to 2024, whoever is employees are created, so that those employees you need. So there might be a large data set also. So in that case, the cluster index is important, or it can be used. So where you want to have faster lookups with the smaller data, so then you can go for the non-cluster index, right? And the storage requirement, there is no additional storage required because you are directly creating the B structure, B tree based on the physical order, physical data order itself. But when it comes to the non-cluster index, so it requires additional storage because you are having a pointers, right? So now without any delay, we will go to the practicals and we will kind of understand how exactly the clustered and non-clustered index will be created. So now we have a customer table, so which is having a, we will see what are the columns that customer table is having, right? So you have a customer ID, customer name and address, and we have around say 5,000 records here, right? Uh, so the customer ID is a primary key, right? And if you see, so I'm dropping one of the columns that is, so none of the indexes are existing now. So if you see, select star from sys.indexes. So I am using MySQL, so the query might be different for Oracle, and if you're using PostgreSQL or any other databases. But here, if you see select star from sys.indexes, it is storing all the indexes, and I'm giving the object ID equals to object ID of customer. That means this particular customers table is holding which are all the indexes. So by default, MySQL will create SQL will create a kind of a clustered index on a primary key. So I've just created a table with a primary key column as a customer ID. So automatically, right, implicitly it has created one of the indexes based on the primary key. So this is the index that as a user we have not created. So it's been automatically created as a clustered index. So clustered index automatically will be created on the primary key column. So, and you can see some of the details of it, right? But if you want to see what is the performance, right? Like, so now there is no, I have created just a cluster index, right? So I will just do a select star from customer name, and there are two people with the same name here. And the idea here is you are querying based on the customer name. So here you will not encounter a difference because so the cluster index is created based on what? Based on the customer ID. But customer name, if you're querying, so you still have a performance lag. If you're so here you might not encounter because you are having just 5,000 records. But if you think about 5 million, 50 million, or more than that records, so then you will have a performance issue definitely, right? Because there is nothing, no index based on the customer name. But if you're using customer ID equals to something, so then what exactly is used is basically the index that you're using, that is IX customer name, uh, customer ID. So that we already saw, this particular index we already saw, right? So that index will be used, right? So now you have something called as set show plan on. So we will just on it and then we will try to execute the query and see. So this is the physical plan, how exactly the cluster, as you can see, the cluster index is already there, but we have not created any non-cluster index. But the important point here is to note is you have a estimated IO, estimated CPU, right? And there are other different stats, but we will concentrate on estimated IO and estimated CPU for now, right? What is the CPU and IO that it is utilizing? So irrespective of like whatever, whether it is using cluster, non-cluster, whatever index, you need to like do a summation of all these, right? Like if you do a sum of estimated IO of this particular column, you get 0.03 because other two are null. Okay. So similarly, now what we will do is we will just set the show different as off, and then I will create a non-clustered index now. So which is based on the customer name in the customer table, and I'll call it as IX customer name. So I'm creating the cluster, I'm creating the index now. So let me see whether the index is reflecting. Yes, the index is reflecting now. So this is a non-cluster index it is showing, right? And now let me on the show plan, and let me query this now. As you can see, now there is a difference. Like there is a something called as, if you really see the argument, right? You can see there is a customer name equal to Emma Martinez. So here also, if you see to the arguments, so in the argument section, there is nothing here. You just see the customer name equal to @1. But here you see customer name equals to Emma Martinez. So that what that means is this is particularly acting as a non-cluster index is activated, and it is trying to search for Emma Martinez using that non-cluster index. And the interesting factor here is, as we discussed, it is about the estimated IO, right? Estimated IO, if you see here, it is 0.03 plus 0.03, 0.003, 0.003, and if you combine it, it becomes around 0.006, right? But here, if you see estimated IO was 0.03, right? Here it is 0.03, which is far bigger than 0.006. Okay, but here the CPU was 0.05, which is two digit. Here the CPU also is more, and the estimated IO is also more in when you are just using the clustered index. But when you are using non-clustered index, so the estimated IO is also less, and estimated CPU is also less compared to before when you are. So this is the query that is specifically we are trying to evaluate the non-cluster index performance, right? So before using the cluster non-cluster index on top of the customer name, so we have to capture the estimated IO and estimated CPU, and this is after applying the cluster and non-cluster index on the customer name column, which reduce the estimated IO and estimated CPU, and this in turn will retrieve the faster results. And the faster results, now you might not be able to understand, right? Like you just get the data very quickly, right? You are getting the data, as you can just off it and do a select star, you get the data in just milliseconds. But when you're talking about millions and billions of rows, so then this will significantly impact. If you see the percentage, it actually improves around 80 to 90% of the performance, right? If you're getting the result in like say 15 minutes, you start getting the results in 5 minutes or less than 3 minutes. So that's the difference that the indexing is making here. So hope this was useful. Thanks for watching.